Isaac Newton came up with 3 laws of motion.
The first law is the law of inertia.
It states that an object at rest will remain at rest until acted upon by an external
It's a statement of inertia because it is saying that an object will remain in its state of motion unless a force acts to change
If an object is moving along untouched by a force of any kind, it will continue to move along in a perfectly straight line at a constant speed.
Then you carefully place the eggs on the toilet paper tubes, and when everyone is out of the way, you smack the cutting board from underneath the tubes with a lot of force.
Ready for this? Let's go. Woo! As you can see, all of the eggs are inside of the water now.
It work! Credit for this one has to go to Sir Isaac Newton and his first law of motion. He said that since the egg is not moving while it sits on top of the tube, that's what it wants to do, not move. We applied enough force for the cutting board to cause it to zip out from underneath the cardboard tube. Basically, you knocked the support out from underneath the egg for a brief nanosecond or two. The egg didn't move because it was already stationary. But then, as usual, the force of gravity took over and pulled the egg straight down to the center of the earth. You want to stop that?
Also, according to Mr. Newton's first law, once the egg was moving, it didn't want to stop. The container of water was interrupted by the egg's fall, providing a safe place for the egg to stop moving, so you could recover it unbroken. The gravity pushed the egg, causing the water to splash out. Did someone get wet?
Now that the girls have done the boring experiment, it's time to do the fun one.
What we're going to do is show you Mr. Newton's first law of motion. As you can see, Hayden is strapped down with duct tape and pillows.
We just want to make sure no one tries this at home. Rachel, hit it.
Okay, so Hayden was the object at rest.
And the four-wheeler was the unbalanced force. And my hair hurts.
So Hayden didn't move until the unbalanced force acted upon him, or in this case, hit him.
Newton's second law of motion explains how an object will change velocity if it is pushed or pulled upon.
Firstly, this law states that if you do place a force on an object, it will accelerate, change its velocity, and it will change its velocity in the direction of the force.
Secondly, this acceleration is directly proportional to the force. For example, if you are pushing an object causing it to accelerate, and then you push, say, 3 times harder, the acceleration will be 3 times greater.
Thirdly, this acceleration is inversely proportional to the mass of the object. For example, if you are pushing equally on 2 objects, and one of the objects has 5 times more mass than the other, it will accelerate at 1/5 the acceleration of the other.
Time for another experiment! For this experiment, we need a pan of flour, a rock, and a piece of paper.
What we're going to do is drop the paper and the rock at the same time into the flour to observe which one makes the bigger crater.
Ooh, let's do it!
Let's look at the results.
The rock made the bigger crater! Why?
The two objects fall at an equal rate. Their acceleration is constant because the velocity is not changing. The rock has a greater force of impact because it has greater mass.
Wow! That's it.
Hey, no, repeat that. I didn't get your face.
Wow!
Another experiment where Hayden gets hurt.
Go. Action.
When I was on my knees and I pushed Hayden, he didn't go very far, but when I stood up, he went a lot further.
Newton's third law.
Newton's third law states that for every action there's an equal but opposite reaction.
This means that when you push something, it pushes you back.
An example of this is if me and Rachel push each other with the same force, nothing will happen because forces are balanced.
The reason why that happened was because when Rachel pushed up against the wall exerted another force back on her. And that's an example of Newton's third law, because Newton's third law says that for every action there would be an equal but opposite reaction. And when she pushed, that was the action. But when the wall pushed her back, that was the reaction!
Newton came up with 3 laws, because he's way cooler than Santa Claus. Inertia was the first of his laws. It didn't seem to have any flaws. An object at rest would stay at rest until an unbalanced force puts it to the test.
The second law of Newton's great mind, and Santa again, Newton outshine. Newton's second law is pretty great. It helps you out when you push a crate.
Go.
Santa gets schooled in the third law of motion. This one made a big old commotion. Every reaction is equal and opposite. Don't run into a wall, because you'll bounce off of it!
You idiot!
Just say next we will talk about Newton's second law.
When Rachel was on her knees, when Rachel was on her knees,
Go.
the easiest way to see this is if I hit Raven,